Good morning. This is software development at its best. We should be looking at moving forward in our software development technologies. So what we want to be able to do is do great things done great. This is what we need to move toward. Our current software failures, I've been looking at software development for about 12 years. What is the issue? And so these are just a few of the main issues that we need to be looking at. We have a lack of progress in all technologies. Computers control our technologies, and mathematics and physics and chemistry and teaching, and every technology relies on computers, and yet we have no software to really maintain any information. So we have our hardware, operating system, application, and version dependencies. So every piece of computer technology that we use, we have dependencies. And this is purely done for financial reasons. We have obsolescence of your own information and procedures. Next week, it may or may not work. Again, purely financial. We have our proprietary data structures. Every application out there creates its own structures, its own logic, and its own way of doing things. So nothing is really open and nothing is shareable. Every application is independent. It has, I don't know of any technology in computer science or anywhere that is shareable or open. Every company says, oh yes, we're open. No, you're not. Our executables, our fonts, our keyboard, our hardware devices, all of our technologies, our characters themselves, the fonts, our numbering system, our CPUs, our hardware is all proprietary. Charging you for access to your own information. Word only works on Word, so if they update their application and you go with it, some of your old documents may not be accessible or have the same capabilities, and so on and so on. So this is horrible. I'm not buying products now basically because sometimes I don't use them for years on end, or they change. So we're kind of stuck in this financial limbo of technology. We have humans in the loop. These are our failures. Every application applies to which value. We have one application that only handles Word. We only have one application that only handles HTML. We only have one application to handle executables, and so on and so on. So it's up to us as a human to figure out what values, how do I change color on which application do I actually do. A lot of this is hidden from us, but in reality, when we're looking at technology, this is what we have to look at. The Army wants a common operational picture, which means that they have data coming from all types of devices, all types of technologies, all types of versions. And so this is a big issue for them, is how do I access all this information? It's an ongoing problem. Every version, yes, they get it to work, but then every new version it obsoletes all their past work. And this is our technology. The Navy battleships. A few years back, I was watching PBS, and they had the military this week show for a half-hour show, and it was about the Admiral of the Navy accepting some new battleships. And the interviewer kept asking him, well, General or Admiral, how do you like your new battleships? Don't you just love them? He wouldn't say anything. He'd kind of nod. Finally, at the end of the show, the interviewer asked him again, and he was very specific. Please tell us how you like your battleships. And he kind of nodded, and he said, yes, they're great, and they're super. The very last thing he said, but the software sucks. And this is our technology. And this is for people spending billions of dollars on this stuff. Now we have failed rockets blowing up, moon landers that are failing to land, and Mars probes, and all kinds of billion-dollar failures that are simple logic errors, simply because we are handcrafting everything. And we have GPS, we have 3 versions, we have 2 versions of our IP addresses, we have CAN bus. CAN bus is the technology that we're using in our cars and trucks and tractors and moving equipment to communicate to all the devices through a centralized processor. It's great, but for each type of vehicle, we have a different technology, and within those we have different versions, which is really not a solution. If I had, from my standpoint as a software developer, if I have to go in there and actually implement a CAN bus, it's all version dependent, it's all hardware dependent, it's all operating system dependent, and then that changes over time. What they're doing is, yes, they're getting it to work for that one piece of software on that one car, and then they sell the car, and it's stagnant. So if you want access to any of that information, a lot of it's proprietary. So we're not getting access to the information that we actually own. 99% of our computer technology is craftsmanship, pure and simple, with dependencies. So we are not free to create new fonts. Not really. New compilers, no. New executables with new operating systems or anything. We're forced into external dependencies that we cannot change. And we have AI coming out and says, oh, we'll create software for you. But what software? Are they going to create operating systems for us, editors, those things that we really want? Are they going to create an accounting system for us? This is purely going to be purely financial considerations. No, they're going to keep us in the same technology that we're in now, because it's the software companies that are writing these things. So we want great software, but to what end? What is it that we're trying to accomplish? Well, one, we'd like no programming be required, no versions. Basically every version causes problems, but we don't want versions. We want forward and backward compatibility, and we want no cost. And what we want in computers is to have the universe of computers as one entity, completely automated, meaning that we should have access to all information. We have, in our internet, we have an infinitely large document. We can get to any page simply with a click. And that's the same way we should be able to do with all of our information, all of our applications, all of our logic, and treat all computers and have this completely automated for us. This is what computers do. Let's let them do it. We want one application responsible for all values, a single copy of logic. So instead of building billions of applications with billions of versions of the same logic, we want one. And then we want to perfect that logic for sorting, and have all permutations of ways to sort, or binary trees, or accountability, or invoicing, or inventory, or all of the other technologies that we're rewriting billions of times. And we want you to have complete control and access to the hardware that you own. This is what we really want. Look, it's my phone. I want to be able to do something with it. It has great capabilities, but I can only do what some programmer allows me to do. Oh, I can't slide. I have to slide to open. I want to just click. And we want complete control and access to the information that you create. You created this document, this Word document, or this map or these spreadsheets. All of that you created, you should own it and have complete access, and no one else should have access. It should not require external applications. We want independent progress by every user. This we don't have. Right now, I've been waiting 50 years for a better editor, a better compiler, a better assembler, a better CPU instruction set, and so on and so on. And we are not getting it. So what we're really saying is, look, I need a new character that represents dogs or whatever it is. That would be progress in my technology, and we need to be able to do that so mathematicians could move forward independent of software companies waiting for somebody else. Our character sets are horrible. Unicode is a god-awful technology. Our font technology is locked up so tight, and our display characteristics, our hardware, and so on. And we want the computer as a useful tool for us. It's my tool. I want to be able to do whatever that computer is able to do. I want access to all the logic and so on. And what we really want is freedom to share my information and logic with anybody for any purpose. Right now we can't. I cannot share my Word document without you having Word. No, I want you to have complete access to your own information and technologies. And I want ownership of your own applications. So you want to create your own operating systems, your own editors, your own compilers, your own accounting system, flight control systems, air traffic control, teaching, school management systems. I mean, we all know what these are. We all know what we want. We're just waiting on software companies to somehow create a technology, and they're not creating technologies because it's not financial benefit to them. And what we really want is trust. I want to be able to trust. I'm a bank. I want to trust that my accounts are safe, that no one internal or external can access this information, and so on. So how do we get there? We do small things done great. We start with knowledge. How do we get knowledge in there? We don't right now. We put in name value. We put in a value 12. What is it? Who knows? We have no knowledge about that. We need to be able to get to knowledge. So we need computer knowledge is different from human knowledge. Human knowledge, we assume a lot that yes, when I lived at this address and the next door neighbor, a friend of mine, I know a lot about that. And that's what we have to be able to get to, be able to put all this knowledge that we know into the system. And computer knowledge is different. It's all blank. Right now, we're only dealing with values. Oh, this is 12. What is it? We don't know. And so what we want to know in everything that the author knows. So I create a document, and when I say pink, I might mean a flower, I might mean a mood, I might mean all kinds of things. And if I have the ability to put that knowledge in, which I don't right now, I can only type in PINK, which to the computer is just 4 bit patterns that mean nothing and don't know what to do with it. We need to be able to get to the point where the computer actually knows what it can do with that and can actually apply logic to that. In searching capabilities and in logic, applying logic when necessary, and to help you as the author, and then be able to share that with other people so they know that you meant, when you said pink, you meant flowers and not just a color. And we want everything that is common knowledge. So we have lists of boys' names, and we have countries and boundaries and graphics and state and zip codes and addresses and phone numbers and all kinds of things. Okay, what country was this from, and so on and so on, and when was that, what area of the country, and billions of pieces of knowledge that we want to get into our systems without effort. And we want to be able to put in everything learned over the passing of time. So yes, today I don't know, but now I do know that, you know, the phone number is blank, but I know that Mary has it, so I'll type in there, Mary has a phone number, call her. It's knowledge now, and we don't want to just put this in as our information. We want it in there as computer information so that we can apply logic to it. Yes, it doesn't have a phone number. Okay, I'll go to Mary's contact list, see if I can find it, and then we can do a billion things. And that's what we're trying to get to, with being able to do the small things. Create knowledge that is actually knowledge, not just some binary bit pattern. For the computer, it knows nothing. And it should be time independent. All of our knowledge should be time independent. So yes, 40 years ago, we used cartwheel as a silver dollar. Okay, so that knowledge still needs to be applied today. No limitations. Everything, every application, we have 1.1 million rows on an Excel spreadsheet. Financial considerations, I guess. No assumptions. We assume everything. Oh, apples equals 12. What is 12? I don't know. And we want no human action required. So all of this knowledge-based thing is that we don't want to have to write programs for this. We want the programs to be created for us automatically. So, like I said, apples equal 89. That's not knowledge. We don't know. We're making assumptions. What is 89? What is apples? Well, if I said, okay, apples equals 89 cents each, or 5 for $2.50, or $32 a bushel until December. Well, what happens after December? What we want is, when I share this value, apples, the system knows to give all this information as a single value. And that's what we got. We can't have this, structures and then apply logic to that. No. This has to be inherent knowledge that the computer knows so that it can apply logic. Okay. If it comes in and says, look, I got 250 bushels per truckload, how much is a truck? So on. So we need to be able to apply logic. And then we can do that just with a little bit of work on our part. But this work is for the benefit of the owner of the information, the creator of the information, the sharing of the information. So we have small things done great, base values. We have numbers. Look, right now we have no control over our numbers. It's very limited. It's a limited range of numbers. It's a very specific format, and we need to be able to put all the knowledge that every system knows about a number. What are the bits, what are the values of the bits, and so on and so on. Vocabulary. We have terms and phrases, and we need to know all that knowledge, and we need to be able to do these great. So that we have all that capability built into our systems with that effort. And symbols. We have different symbols for transformer. Right? On a map, this is the triangle or whatever, the transformer, and here's a switch and so on, and diode and so on, and icons. Okay, we use this icon to open a file or close a file, and these all need to be. I spend more time on symbols and icons than I do on programming. The logic is simple. We have two things to do: get the value, which is most of our effort because it's proprietary and we have to figure out where it is, how to get to it, and all these things, which really should be done for us. And then we spend the rest of our time on symbols and icons just so we can tell the user what to hit. The logic is simple. Change the color. Okay, boom. Lines. We have lines. We have different types of lines. We want to be able to do these things great. So that you want to put railroad tracks in, or a fence line, or a boundary line, and color it and do all these things. We want to be able to do all that. Same way with text. Text, we want to be able to do. Look, we want to qualify every piece of text. Gone with the Wind. I'm talking about a book. That knowledge should be put in there, hidden but associated to the text that we put in our documents. We want intelligent documents, and intelligent, so that we're not trying to, this AI bullshit of, oh, I'll go derive this information. No, you cannot derive things that do not exist. If you try to derive Shakespeare, I think there's 15 different variations of everything he said. Characters. We need to be able to create our own characters. We can't move forward. Our whole technology is stagnant on a 1868 typewriter. Pictures. We need access to pictures. I took the picture. It's my picture. Nobody else can access it. No one else can do anything unless I say so. And I need to access it. And the logic is trivial. Video, same way. I have a video. I took that video. It's mine. I want to be able to control and access and change it or reorder it or edit it or do whatever I want to with it. And that's my prerogative, and that's what our system should do. Not have to buy 15 different products and hope to God we can, and next year it doesn't work. Dates should be fixed, not durations. Money, we have no currency. We have no way to manage it other than a specialized application. Time is a duration. It should not be a duration. It's 12:30 at night. Right now we cannot tell what day it is. And then we build great things with small things. And we really have a single piece of logic to handle all base values. Take these small things and we create them so that we can manipulate them and do whatever we want to, and then we can create mathematics. So we take the small things and we build great things like mathematics. And then with that, we can take mathematics and we can combine that with other technologies to build physics and all the laws of physics and so on and so on. And so this is a single piece of logic from the computer side. We don't care what the name, what you call it. I mean, the computer doesn't. I mean, we can tie that. We can associate mathematics to other technologies and other things and other purposes. But that's what computers do. But all of this to the computer is just one piece of logic. And it's probably only 300 or 400 lines, literally. It's just, computer software is utterly simple. It's our complexity that we built in, because everything's handcrafted. We have to figure out, oh, well, how did he do this? What did he mean by this? And so on and so on. So then we get to great things done great, which is what we're after. We want users to control the hardware that they own. All hardware. Look, I need to be able to do this. We want users to control the information they create, period. Absolute control, absolute access. Without cost, without having to buy applications after app and have everybody else buy the same applications. No, I want to be able to share this with you. It's a map. I'm doing a refinery, and these are the designs on the foundation or whatever it is, and this is detail A or whatever. And we want to be able to share that, and you be able to mark it up and send it back to me at no cost. This is what computers do. And yet we're stuck in this financial burden of no progress. And so users control all security. We don't let external dependency, somebody else's security is not our security. It's my phone. I want to lock up my own transmission or my email or all my, I want security on my hardware. So users have access to all logic information on their hardware, period. So nothing's on there that he does not know about. All logic should be known, all information. If I'm running a bank or a hospital, I need to know what's going on. I cannot have this proprietary systems that I don't trust. I don't trust anybody. Users can change the technology at any time. This is progress. Look, I found, yes, the hardware can do that, and let me do it. Look, I can stop and inject new technologies into my own procedures at any time. The automation of all logic. So basically, this is all done for us. We don't do anything. We just say, look, I need a new compiler, I need a new editor, I need a flight control system for 2-mile runway or whatever. We qualify it, and to the computer, it's just qualifiers. This is what computers do, and this is what we want to get to. Dynamic operational procedures means that, yes, okay, I'm analyzing this, and I find that some of these values I'd like to collect, I want to be able to do that right there. Not write another application to go in to save that information off. No, I need to be able to dynamically adjust and inject testing procedures or whatever to, and try new combinations immediately, not wait for some software developer 6 months to come up with this thing. I was working at Lockheed Martin, and they were merging 2 companies and moving employees from one company into another company. And I was talking to the manager somewhere on the phone, who knows where. And we were talking. I said, well, what we really need is, it was none of my business, but I said, look, well, I'm writing a software to validate this so they could do charging, anyway, financial things. And I said, look, what you need to know is, who's on this company and who's on that company, which ones have been moved and which ones are in both companies and so on. So I wrote her a bunch of complex SQLs that gave her all these reports. That very quickly. I mean, to me, it was very trivial. And I gave it to her. I said that day, but it took me another day or the next day when I found time to do this. Anyway, I did this. I sent them to her. She loved them. She says, I've been asking for this stupid report for 3 years. No programmers are required. That's what we've got to get to. The user controls his environment. No external access or dependencies. Look, once you put a dependency in there, we're dead in the water, and that's all we have now. We're dependent on everything. And so the end result of being able to do this is software companies will disappear. We don't need software companies. Software, the logic is, go to the store and buy a loaf of bread. I can tell that to anybody, and that's the same way doing inventory or doing an accounting system or whatever. These are not unknown technologies, and yet we treat them as such. Jane, which is the system that I'm building, is an action automation. So actions are applications, if you wish, or a command. So we have 3 technologies. The first technology is an action request technology. This basically, if you wish to, this is the thing that everything talks to determine the logic and the information to perform the action, and actually compiles that. And then we have an information technology. This is for the distribution and management of all information, no matter where it is in the world. And this technology is being called by the action request technology. It says, okay, I need a value 10. Okay, on this particular hardware, that bit pattern is this. And so this is all hardware independent, software independent, application independent, so that we don't hard code any of this technology into applications. This is all done dynamically, and then we can save it. Okay, I need a compiler for x86. Fine, they can compile it and build it. No, I want it for an ARM, or I want it for a RISC, or whatever CPU technologies that are now or in the future. We need to be able to do this instantaneously. And then we have a logic technology, which is simply the depository of logic. It doesn't do anything. It's there. It's not tied to information or anything. It's simply the logic, and then that information is built in by the action request technology. And so these are how our applications, and we only build 3 technologies to build all other technologies. So you want mathematic editors or mapping editors. So basically we have one editor, and it can handle spreadsheets and records and tables and music and dance and all the other technologies that are ever built. And as we come up with new technologies, space technologies or hydrology or, anyway. So this is the system, literally. There is nothing more to it. And these are all fixed. The one is the only thing that is really, and this is a single piece of logic. Literally, these are not building. I'm trying to get down where we're not building billion line applications. We don't need them. Here's an action. Move 10 to register 1. This is one of our first actions that we ever built in hardware. It's an action. So now we call the action request from wherever and says, do this for me. Or we could say create an accounting system for selling light bulbs or bullfrogs or whatever else you want, or manage a 10-bed hospital or flight control system, or or land on the moon or whatever. Our technologies can move forward. So we want independent progress by everyone. Computers should we're dead in the water as far as I'm concerned. We have not moved anywhere in computer technology in 50 years. Software technology. Hardware, yes, it's great. Yes, it's better. But software is killing us. All right, well, thank you for your time. I know this is vague and not understandable, but this is what I'm trying to get out, is to move forward, to reduce the cost or eliminate the cost for technology, for software, so that we can create better training and teaching in hospitals and science, mathematics, and all technologies. Well, thank you for your time. Have a great one. Bye now.